Kirchoff current law. Now, what is the statement of this Kirchoff current law? Let us see that one. It states that the algebraic sum of all currents entering and exiting a node must equals to 0. You already know what is node. Node is what? A point at which more than one or two branches are joining. For example, this one, this node A. Here you can see number of branches are joining here. Okay, this is called as node. What it is saying? It states that the algebraic sum of all the currents entering and exiting the node must equals to 0. So you can say here I1 is entering here. You can see the arrow mark of the current I1. It is entering. I2 is entering and I5 is entering. Who is exiting? I4 and I3. The algebraic sum of uh, currents in entering, that is I1 plus I5 plus I2. This must equals to what? I4 and I3. Or you can say I1 plus I2 plus I5 minus I3 minus I4 equals to 0. This is what the Kirchoff current law states. Okay. Another statement is that, let us see that one. The algebraic sum of all incoming currents must equal to the algebraic sum of all outgoing currents at a node. Okay. Whatever incoming currents are there, the sum of that incoming currents and that must equals to the sum of outgoing current. Okay. According to this first statement, you can write like this: I1 plus I2 plus I5. I1, whatever coming in, I will consider them as a plus I plus I1. Plus I2 is coming in, so I will consider plus I2. I5 is coming in, so I will consider plus I5. Now I3 is going out, right? So I will consider it a minus I3. Okay, I will write this one as I3 as a minus I3. Why I am considering minus? Only thing is it is going out. All are coming in. Whatever coming in, I will consider them as a positive. Whatever are going out, I will consider them as a negative. So minus I3 here and minus I4. Why minus I4? Again, I4 is going out from this node. Okay, so you can write like this also. You can take this I3 and I4. You can move to that RHS side. So it will become like this. Okay, equation number 1, isn't it? Now you can see, you already know that what is the current. Current is the charge by time, rate of change of charges. Okay, motion of the charge with respect to time, q by t. So just what I do, just I will substitute the q by t in this equation number 1. So since it is a I1, I will take it as a q1 by t plus q2 by t plus q5 by t equals to q3 by t plus q4 by t. For I4, I consider just okay. Now, if I cancel out the t here, and the denominator here also I have t, here also I have t. So just I will cancel out this. What I remain is what I got is q1 plus q2 plus q5. That is equals to q3 plus q4. Okay. From this equation number, let it be equation number 2. From this equation number 2, what we understand, that is very important. You know how to apply the Kirchoff current law. You already know how to apply this one. You know you got this. Whatever coming in, take them as a positive. Whatever going out, take them as a negative, and equate them to 0. That is what Kirchoff current law is. Now, what it actually states, or what is actually this one is. So you can see here q1 plus q2 plus q5, that is equals to q3 plus q4. The sum of charges entering the node, q1, q2, q5. What are these? These are the charges entering the node. Okay, that is equals to what? Q3 and Q4. Sum of the Q3, Q4. What are this Q3 and Q4? This is the sum of charges leaving the node, or sum of charges exiting the node. So you can say that charge is conserved here. No charge is wasting here. Whatever charges are entered, likewise, same charges is exiting the node. Okay. So that you can call this as KCL is just a law of conservation of charges. What KCL is? KCL in the sense Kirchhoff current law. This is a law of conservation of charges. Okay. For example, you can see here, if Q1 is if Q1 is 2 coulomb, this Q1 is 2 coulomb plus Q2 is again 2 coulomb, and Q5 is again it is also 2 coulomb. Then Q3 will be 3 coulomb plus Q4 is 3 coulomb. Here you can see it is total 6 coulomb, and on RHS side again it is a 3 plus 3 6 coulomb, like that, likewise. So I think you didn't see that one. Sorry. You can see it. Q1 is 2 coulomb, again Q2 is 2 coulomb, Q5 is again I will consider it as a 2 coulomb. Charges will be taken in coulombs. Okay. So Q3 is I'll consider 3 coulomb, Q4 3 coulomb. If you sum this one, you will get 6 coulomb on the LHS side, on again 6 coulomb on the RHS side. So charges whatever coming in, 2 plus 2 plus 2 charges are coming in, they are divided in such a way that again it equals to 6 coulomb only, that is 3 plus 3. Likewise they will divide. From this you can say that charge is conserved here. Kirchhoff's second law, again it is called as the Kirchhoff voltage law. Kirchhoff's second law, it is not just Kirchhoff voltage law. What its statement, what it states? Let us see that. Okay. It states that algebraic sum of all branch voltages must equal to 0 in any electrical closed loop. Listen carefully once again, I will repeat. It states that algebraic sum of all branch voltages, algebraic sum of all branch voltages must equal to 0 in any electrical closed loop. In KCL and the Kirchoff current law, we considered a junction. We considered junction. I1 is coming, I2 is I1 coming, I2 is also coming in, I3 is going, something like that. I4 is going out, and I5 is also going out, like that. What we considered here? We considered what? Junction here or node here. Point node A we considered for a KCL. For KVL, what we consider here? For KVL, we consider a loop. Closed loop, we consider closed loop. Already you know what is a loop. It is a closed path of the electrical for the current. Closed path for the current, that is called as a loop. Okay. I will, for example, this is one closed loop. A, B, C, D, A. A, B, C, D, A. This is a closed loop. What it states is the algebraic sum of all branch voltages must equal to 0 in any closed loop. I will consider this closed loop A, B, C, D, A. What is the branch voltage? So, what is the, for example, this voltage is Vs, okay, and voltage across this resistor is V1. Let it be R1. Voltage across this is V1, and let it be R2, and voltage across this be V2. The algebraic sum of all the voltages in this loop, that must equals to 0. So that means Vs plus V1 plus V2, that is equals to 0 something. Okay, but there is some method is there to apply the Kirchoff voltage law. So let us see. Let us do that one. Here you can see, here you have minus polarity. Battery. This is the minus terminal of the battery, and this is a positive terminal of the battery, isn't it? You know this is a positive terminal of the battery. This one is the negative terminal of the battery. This positive terminal is connected to the passive element. Resistor is a passive element. So here it will get the positive polarity. The resistor don't have positive negatives, but when you connect the battery, it will get the positive polarity on the on this positive side of the battery. Here you will get a positive polarity. Here you will get a negative polarity. In the same way here also for this resistor too. Here it is connected to negative of the battery, so this terminal become to negative polarity. This terminal become positive polarity. Okay. Now see how to apply this KVL. When just from negative to positive, from negative to positive, I will consider this one as a positive voltage. Listen carefully this one. For negative to positive, from negative to positive, from negative to positive, I consider this one as a positive voltage. Okay. From positive to negative, I consider it as a negative voltage. You can interchange this one, no problem. For my sake, I consider from negative to positive, consider from negative to positive, that will I consider a positive voltage. If you count from positive voltage to negative voltage, the negative terminal, then that voltage will be negative voltage. I will consider like that. Okay, actually current how it is flowing? It is flowing like this, isn't it? From positive terminal, it is coming back to the negative terminal. Current I is flowing like this. Okay, so I will go in the direction of current only. Current is flowing in the clockwise direction, isn't it? So I will go like this only. From I will consider this for this battery from negative to positive. That is what I already told is to the positive voltage. So plus Vs. Now again, I will move like this in the clockwise direction only. Here I got positive terminal. After I am going to negative terminal, positive to negative. Which one is that? That is negative voltage. So I can minus which voltage is there? V1 is there. So minus V1. Again, I am moving in the clockwise direction. So I will approach first positive terminal. Again, I am getting negative, positive to negative. So this terminal will be what? This voltage will be what? Minus voltage. Again, V2 is there. So I will write minus V2. That is equals to what? 0. According to KVL. This is how you have to apply the KVL. Kirchoff voltage law. Are you getting this? So what I did, all branch voltage. Here also this is also one branch. Here also this is also one branch. Here also it is one branch. The algebraic sum of all branch voltages equals to 0. Algebraic in the sense what you have to consider the polarity. Here you can see the definition. You have it states that algebraic sum of all branch voltages. Branch voltages are what? This one, Vs, V1, V2. These are all branch voltages. But algebraic sum in the sense what you have to consider the its polarity. Polarity in the sense what? Positive, negative, you have to consider the thing. That is this thing. You have to consider these things. Okay. I consider minus to positive, that is here to here, I consider positive voltage, and positive to negative, I consider negative voltage. So positive to negative, I consider negative. That means minus V1. So you have to take minus V1 here. You should not just Vs plus V1 plus V2 is not equals to 0. Vs minus V1 minus V2, that is equals to 0. This is what KVL and how to apply the KVL. Is it okay for you? So if you see some again this Kirchhoff voltage law, it is also law of conservation of electric field. Kirchhoff current law is the law of conservation of charges. But the Kirchhoff voltage law is the law of conservation of electrical energy. How it conserves the electric energy? Let us see that one. Okay. So here you can see V1. What is the V1? V1 is the you know already this one Ohm's law. V equals to I into R. So if you consider a V1, V1 equals to I into R1. Okay. What is V2? V2 equals to I into R2. Why I into R2? Why I into R1? So you can see here. Here I have resistor R1 and resistor R2. But the current I is same here. Whatever current is flowing here, I, that same current will flow through this resistor I. Current is remaining constant. Current is not changing. Whatever battery producing the current, the same current I is flowing through this circuit. Who is different? R1 is different, so you have different voltage. R2 is different here, so you are getting V2 different. So you should not I1 you should not take I1 and I2 you should not take that because same current is flowing in R1 as well as R2. Okay, so V1 is I into R1, V2 is I into R2. So just substitute this in equation. In this equation, okay. So you will get Vs equals to what? Just take the V1 and V2 on the RHS. So you will get I R1 plus I R2. This is what your Kirchhoff voltage law. Otherwise, simply you can say that the EMF source, whatever source is there, battery is the source, isn't it? That source voltage Vs equals to what? IR product, sum of IR products. IR products in the sense what? Current into resistor plus current into resistor. You have to do like this. Just simply you can do like this also. So voltage law. Another definition we can say in any closed path, the voltage of the active element is equals to sum of IR products across the passive element. Like that also you can do. Okay. Another thing is, you know this one. Vs equals to from this equation you can write Vs equals to what? V1 plus V2, isn't it? So you already know that voltage voltage equals to what? Electrical energy electrical energy divided by electrical energy divided by charge. You know this equation, you must know. Okay? If you don't know, just remember this one. What is voltage equals to what? Electrical energy divided by charge. So you can put this equation in this equation number, or either it's one or two later. So Vs, in the place of Vs, I will write Es divided by Q. In the place of V1, I will write E1 divided by Q. In the place of V2, I will write E2 divided by Q. Okay. Now I will just cancel out the Q on the denominator. So I will get this equation. Just I already written here. You can see Es plus Es equals to E1 plus E2. This Q will cancel out here. Okay. Just will remain is Es equals to E1 plus E2. Now you what this equation says? If you observe carefully, this is what Es is what energy supplied by the voltage source in the circuit. Es is what this is electrical energy. Okay, that is what supplied by the source, voltage source. Here Vs is what voltage source. This is supplying the Es energy. This is only supplying the energy. These are consuming R1 and R2. They are consuming the electrical energy. Who is supplying? Vs is supplying. So Es is what energy supplied by the voltage source in the circuit. That is equals to what energy consumed by the passive elements in the circuit. Who are the passive elements? R1 and R2. They are the passive elements. They are consuming the electrical energy. So you can say that we can say that KVL is the law of conservation of electrical energy. Whatever you are giving the energy, that energy is consumed by these resistors. Okay, what is this is giving some energy. That exact all energy is consumed by this R1 and R2. Either they are converting it in the form of heat, or they are converting in the form of electrical energy or magnetic energy, whatever it may do. But the whatever energy you are giving, electrical energy from this VS, this every energy is consumed by this R1 and R2. So energy is not wasted here. It's exactly consumed. Whatever given, that is totally consumed. So you can say that a KVL is the law of conservation of electrical energy.